Everyone, I hope you're having a good time at the Biomedical Engineering Conference. And so I thought this would be a good opportunity for me to make a quick video talking about how you can custom write files for 3D printers or CNC machines by directly setting out commands in a programming language. In this case, I'm using Matlab. But you can do this in pretty much anything you want to. So if you wanted to make a C program or Python or whatever it is, you can do largely the same thing. And what you're doing is you're replacing the slicer with a custom code that generates geometry based off of user input or even loading off of files like the slicer does. In this case, it's a little bit more manual, but we'll walk through this and we'll look at the output from this file and we'll do some debugging if we run into any issues. So in this case, I have a file I want to use to generate a series of lines that form a box that is porous. So it's going to have basic cross-hatching of horizontal and vertical lines. And I'm going to specify the size of the box as well as the spacing between the lines. And then the porosity will be a function of that spacing. So the larger the spacing, the more porous the box will end up being. First thing I'm doing here is I'm specifying the name of the file. So in this case, I have textbox.txt. You can specify whatever extension you want in there. The text extension is nice because it will make this readable by a word editor. And so I can open this and look at the file after it's done fairly easily. The next thing here, we're actually opening the file. So I have file name going into this. I'm using this fopen command. The W is a modifier. Again, whenever you see a Matlab command that you're not sure what it does, the easiest thing to do is just go into the help menu. You can type that in, and you can make sure you're using the appropriate syntax for whatever you're using. In this case, I want to use basically a text file. So I have different encoding inputs on here, which I should be able to see. What's the W option? I was like here, W. So create a file that's open for writing. So I'm going to write to this file. So pretty straightforward. So I'm going to open a file that I want to write to, and then I'm using the fprintf command to write to that file ID. And then the thing that I'm sending out here is just text. So this is a character string. The G90 is a G-code command, and then anything after the semicolon in the text file is comment in my machine code. So I'm setting absolute positioning. I'm using relative positioning for E. I'm allowing for cold extrusion. I've set the end stops. I've set the bed temperature and the extruder temperatures. Anything that's a \n, that's a character code for a new line. So I want to make sure that all these things, as I'm writing them out to the file, I'm getting new lines and they're not all just kind of in one long character string. And that's mostly for it to be human readable and for the code to know when a new command is being sent. And then we have some initial positioning here, just setting the Z height to 0.02. We're doing an extrusion of 0.5, and then I'm going to an initial position of 100, 130. So that way I'm above the bed before I start the print. And then the next thing I have on here are some specifications for the box size that I want to do. In this case, I've specified each of these in millimeters. So I have a length, a width, and a height. I have a spacing for the lines. In this case, I have 1 millimeter. I have an extrusion distance per unit length. So I want to extrude kind of a set amount based on how far the needle has moved or the extruder has moved. In this case, I'm using 0.01. So when I move a length of 20 millimeters, I'll extrude a total distance of 0.2 kind of millimeters of filament from the extruder axis. That's because I'm using this in a bioprinter. And so we're actually extruding some gels with this, and a small movement of the crosshead leads to a fairly large extrusion because the diameter of the cylinder that we're extruding from is significantly larger than the diameter of a typical filament. So we have to use fairly small numbers there. And then I have an initial position. So whereas the start of the box, in this case, I'm calling this the bottom left corner. So I'm setting it at an X and Y position of 100 with a Z of 0. And I have a variable here that allows me to alternate between doing a left or kind of left-right a x-axis print and then up, down, or kind of in, out, a z-axis, or sorry, not a z-axis, a y-axis extrusion. And then this is really where most of the code gets written, is in these for loops. And what I've set up is I have z is equal to 0 by an increment of 0.02 to whatever the height is. If I wanted to have a variable kind of layer height, I could change this to make that a variable and set that. Basically, what I'm going to do is however tall I want my box to be, I'm going to have a certain number of layers where each layer is 0.02 millimeters thick. And actually, probably this doesn't make a lot of sense. It probably makes more sense to start at 0.02 and not at 0, because we actually don't want the extruder to start at the bed. We want to start something above the bed. So something like that, where we're starting at the first layer height, and then we have an incremental layer height, and then the rest of them going forward, probably makes a little bit more sense. And then what we have here is I don't need to set the Z height every time I call this. So I'm going to set the Z height at the start of the layer. And then for all the subsequent ones, I'm only going to change the X and the Y and the extrusion distance. So I have a Boolean qualifier here that checks to see if flip is greater than 0. And if it is, it'll do an extrusion kind of across the Y, and I'll go into that in a second. And if it's not, if it's less than 0, then it's going to go down to this else statement. It's going to do the opposite extrusion, which I'm going to modify this kind of in live so you guys can see what that works like relative to the X. And then in the end, I make the flip the opposite of flip. So it goes from being +1 to -1. So on the next iteration of the for loop for the Z height, it's going to print in the opposite direction. So let's zoom in on this a little bit and take a look at what this set of code is doing. So for X is equal to X0, which is my starting position in the X. And then I'm saying at a distance of 2 times the spacing to whatever the X0 plus width is. So it's from the starting position to the width of the box. What I'm going to do is I'm going to start at X, and then I'm going to go at X, Y0, so the Y0 position. And then I'm going to go forward, right, a length of whatever the length is. And I'm using an extrusion of the ED length, which is a function of the length and my unit extrusion distance. All of these character codes inside here, the %5.1f, the %5.1f, that's going to be a floating point digit with 1 decimal with 5 characters total going into that array. So that's going to replace these 2 percentage values in here with the values of X and my Y0. And then on this next one here, since we're increasing that between this one and this one, these first two, or these 2 lines inside this loop, we're going to move along the X value a distance of length. And then what I'm going to do is I'm going to move over 1 space, and I'm going to go from that new Y position back to the original Y position. So this is just going to go out, over, and then back down. And then it's going to give a new value for X, which is the spacing times 2. So 2 spacing, which is going to be 1 more than I'm at currently. And it's going to go out, over, and back. And it'll repeat that until the X is equal to the X0 plus the width, which is what we want. So if we want to do the same thing in Y, it's going to be very simple to modify this code. We're just going to generate lines in the Y direction. We're going to say our Y is equal to our Y0. We use the same spacing. If we wanted to have a different spacing in the X and Y, we could change that. And then plus our Y0 plus the length. In this case, we went to the width, right? And then we moved along the length. In this case, we're going to go to the length and we're going to move along the width. So we're going to say our X0 is the starting position. And our Y0 is going to be the variable kind of start of the loop. And then we're going to go to X0 plus width. And we're going to stay at the same Y value. So in this first one, we stayed at the same X and we only changed the length. This time we're staying at the same Y and we're changing our width. And again, so I'm going to use the ED width instead of the ED length because I already updated that one before I started recording. But you can see that that kind of matches up. Go down to the next line, we'll do the same thing. We'll say we're going to go from X naught plus width. And we're starting kind of out. We want to come back in. And we're going to do Y naught plus spacing. So in this third line, we've got X naught or X plus spacing, Y plus spacing, and we've got Y naught plus length. And this one we got X naught plus width. So we're kind of making sure that we're switching each of those parameters appropriately and consistently. This last one, we're going to go going back to our X naught. And we're going to stay at Y plus spacing. So let's just look at it one minute. So we go for X plus spacing, Y plus spacing, Y plus spacing, Y naught plus length, Y naught plus length, Y naught, X naught plus width, X naught plus width, X naught. So that logic makes sense. And then again, we got the flip and return. After we've gone through all the different layers of height, the next thing we'll do is we're going to raise up the print head. So whatever position we ended at in terms of our X and our Y in this last piece, we probably want it, I don't know which of these is actually going to end last, but we should be very close to our X plus or our X naught plus width. And our Y naught plus length. That should be basically the end of our code. Because then not necessarily true, because we're going to come back to that original position. Probably what we should do here is not set the X and the Y value and just go to a new Z height of 30. So we come up out of the extrusion. So let's do that. Let's just take these X and Y positions out. And then rather than trying to guess kind of which portion we ended at, or we could use the flip to figure out how we ended, we'll just change just the Z value. That makes more sense. And then we'll return to the original starting position, and then we'll close the file. So let's save this and then run it, and we'll take a look and see if the file that we get as an output from this matches what we really want it to do. I didn't hear a ding, so I'm assuming that that ran. We have something that's unsuppressed that gave us a 19. So I might want to take a look at that and see if we really want that output to include there. It's like this F command. It's not suppressed. I don't see anything else that's not suppressed in here. So that's probably what output of the the 19. Maybe that's the file ID. I'm not sure. There's our text box, and we can see here we have our setup code. We've got our initial height. We're going from X100 to Y100. We've moved 20 in the Y and extruded. We moved 1 in the X, and then we move back down 20 in the Y. And we see we alternate as we slowly increase the X value until we've got one whole line. Looks like we actually overshot our width a little bit because we're doing that spacing by 2. We could fix that if that's really important to us, or we just allow it to be, 1 millimeter wider than it was programmed. Depends on what your application for this really is. We moved to the next level up, and now we're moving in the Y, slowly alternating between the kind of the width and initial position of the X. So that looks good. And then we can see we have each layer going through and kind of repeating. We should see all of these go through until we have a Z height of 4 millimeters. So let's go down. 3.6, 3.8, there's 4. And then we have raising up out and returning to the 0 position. So really that worked the way we expected it to work. And we could modify this to do whatever we wanted. This is maybe a little bit boring because we're only printing still 2-dimensional structures. If you wanted to, you could print three-dimensional paths using non-planar print techniques with this kind of a code. So if you wanted to print something that went kind of up and down as opposed to just in plane, you could do that. And that would be probably one of the main advantages of writing out custom code, is to allow you to have tool paths that are non-standardized. And sometimes those tool paths may be more efficient than using just a regular slicer or something that came out of either SolidWorks or something else. Hope you all enjoyed that, and let me know if you have any questions.